we know that a linear function takes the form y equals mx plus b, and that m and b, changes in m and b affect the graph of the linear function. So same goes with the quadratic function. So a quadratic function takes the shape of a parabola. So a parabola looks like this U, or it can be an upside down U. It's curvy. So the general standard form of an equation that's a quadratic is y equals ax squared plus bx plus c, where a, b, and c all impact the shape of the graph, which is called a parabola. So the first thing to notice is that ax squared, so a is the coefficient of x squared. So if a is positive, the parabola is going to open up. So if the leading coefficient, x squared, has a positive number in front of it, or is positive, then it's going to open up, so it looks like this. And if a is negative, it's going to open down, and it's going to make an upside down U. So we call, when it opens up, this is called a minimum value, and when it opens down, this is called a maximum value. This is the minimum point in the function, and this is the maximum y value of the function. So also, the value of a also makes an impact on the graph. So the farther away a is from 1, or actually, okay, the greater the number is, the absolute value of it, so even if it's a negative, it's going to make it narrow. So the parabola is going to be narrow. So it can open down and be narrower, and it also can open up and be narrower. So for example, if you had -5, that's going to open down and be narrow. Same with if you had +5, because the absolute value of both of those are greater than 1. On the other hand, if you have the absolute value is less than 1, it's going to be wide. So for example, if you had -1/2 x squared, if you took the absolute value of it, it's less than 1, so it's going to be wide and it's going to open down. So this is what I mean by wide. It can either open down or it can open up. Now B affects the graph. It affects where the vertex is going to be at. So I'm just going to do, if B is 0, then the vertex is on the y-axis. So the vertex is the minimum or the maximum. So a minimum value is right here is a vertex, right here is a vertex, 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 vertex. So if B is 0, so if there's not a B value, then the vertex is on the y-axis. Otherwise it's going to shift it left and right, but it doesn't shift it based on what the value of B is. So if B is 3, it's not like it's shifting it right 3. It's more complicated than that. So you just have to know that if B is 0, it's going to be centered on the y-axis. So for example, it looks like this. So if this is my coordinate plane, B is 0. See how the line of symmetry is on the y-axis? That's what it would look like. And the last characteristic is the C value. So C is the y-intercept. So it could be not centered. The C would be this value right here, or it could be centered on the y-axis. The C value would be right here. So C is the y-intercept. Okay, order these following graphs from narrowest to widest. So what you want to do is take the absolute value of each of these numbers, and then narrowest means the ones that are greater absolute values. So I'm going to take the absolute value of each of these coefficients. So I'm going to get 1/4, 3.1, and 10. So if you think of it on a number line, if I put on a number line 0.1, 1/4, 3, and I guess 10 would be way over here, 10, the ones that are over to the left are going to be wider. So these are over here are going to be narrower because the absolute value is greater than 1. So the narrowest one is going to be this one. Then the next number, this is the second narrowest. Then this is the third narrowest. This is the last narrowest. Okay, another example. Without graphing, describe how each graph differs from y equals x squared. So what's going on with a, b, and c here? So y equals ax squared, what is this -3 doing? Well, this is going to open down. So I write open down. And is it wider or narrower? It's narrower because the absolute value of -3 is 3, and that is greater than 1. And then the y-intercept is 4 because the c value is 4. Second example, this is positive 1/3 x squared, so it still opens up. And then this, because the absolute value of this is less than 1, it's going to be wider. And the y-intercept is -2. Now, the b value is 0 for each of these. See how there's not an x value? So that means that both of these graphs are going to be centered on the y-axis. So this one, the y-intercept, is 4. So I'm going to go up 4, and then it's going to open down and be narrow. Now the second one, the y-intercept is -2, it's going to go open up and be wide. Those are the general sketches. Okay, then if you have to graph a few, first I'm going to graph y equals x squared. So what you're doing is the function is you're taking the input and you're squaring it. So if you input 0, you get 0. If you input 1, you get 1. If you input 2, 2 squared is 4. If you put in -1, -1 squared is 1. If you put in -2, -2 squared is 4. So this is the general shape. Now if I graph x squared minus 3, the function is square the number and then subtract 3. So -2 squared is 4. 4 minus 3 is 1. 1 squared minus 3 is -2. 0 squared minus 3 is -3. -2 and 1. So in blue, I'm going to graph the function -2, 1, -1, -2, 0, -3. So it looks like this. Now the last thing I have to do is label each vertex. So vertex is an ordered pair. So this ordered pair is 0, 0, and this ordered pair is 0, -3. And you can kind of see that this function has just been shifted down 3 units. Next one I'm going to graph -x squared minus 1. So this is a y-intercept is -1 and it's opening down. So what I'm going to do is I'm going to show plugging in -2. So it's going to be the opposite of -2 squared minus 1. So this right here means it's the opposite. So I have to do order of operations. I do negative squared first, which is 4. -4 minus 1 is -5. And then I do the opposite of -1 squared minus 1. So this is -2. If I plug in 0, I get -1. Now because this has no x value, the b is equal to 0, it's actually centered on the y-axis. So I can use symmetry right now to fill in my table. So that means that if this is the y-intercept, this should be -2 and this should be -5 for it to be symmetrical. So I plot -2, -5, -1, -2, 0, -1. And I want to make sure when I make my parabola I put arrows at the end and I make it curvy. I need to label the vertex, so the vertex is at 0, -1. So connect the dots to make it curvy. Okay, list 5 facts about the graph. So first I look at my A value. The A value is 3. So I'm going to write that it opens up. Now, if the graph's going to open up, I'm going to write that it has a minimum value. Now I'm going to look at whether it's narrow or wide. It's narrow because the absolute value of 3 is greater than 1. And then the y-intercept is 2. And because there's a b value, it shifted from the y-axis. So I'm not going to write, or you can put it shifted left or right. It's not centered on the y-axis. So remember, just because that v value is -1 doesn't mean that you're shifting left 1 unit.